Okay, so today we're going to try to hit all the topics that kind of like fall in between the cracks, like finding the domain and range from an equation, and finding the domain and range inverse of that equation or function. And so as you can see, what we have is we have this function right here, and I want to find its domain and range. And that's not really easy to do because I don't have a picture of the graph. So I have no picture of the graph to know what it looks like. So here's the first thing I'm going to do. I'm going to get a picture of the graph. So how I'm going to get a picture of the graph is we could either try to graph this thing by making an XY table and plugging some points into there and spitting out some Y's and kind of see what shape it makes. For this thing though, we're going to actually use some graphing software. So let's use some graphing software to do this. Discard those notes. Okay, and if I remember my function, it should be 2x to the second plus 8x plus 3. So I'm going to zoom out a little bit so I can get a better idea. It looks like the bottommost point is -2, -5, and it keeps going up in the x direction forever. So we can see, if we're looking at its domain, we can see it kind of goes, if I keep scrolling out and keep scrolling out, we can see that eventually all the numbers are going to be hit. Because even though it looks like it's really close, that's to -50 already, and if I keep going out, it's already to -100. So even though that's really, really skinny, eventually it will get all the x values in both directions. And it has all the x values. So the x values is all real numbers. And if I look at the y, it goes from -2, and that keeps going up forever. So if I go back here, I can put in what we found, and we found, that the domain is all real numbers, and the range went from -2 to infinity, so I don't have to put anything over in this spot right here. Now we're going to think about the inverse. And what an inverse does is it switches the x and y's. Well, if domain is just my x and range is just my y's, those should flip. So now my domain should be this, and my range should be this. And then we're done. Let's look at the last example. So in the last example, I have this kind of situation where we have h of g of x. And in this, we want to solve it just like we've done before. So we want to plug x into g. So we're going to plug x directly into g, and here's what we will find. That when we plug x in for g, it's already like that. So I have 4x plus 1. And that's what I have. So that's my answer. Now I'm going to take this answer and I'm going to plug it into h. So I should have x, instead of x, I'll have 4x plus 1 squared minus 2. Because I took x, I plugged it into g, which kept it the same, and then I took g and I plugged it into h. Now, this is a good answer, except for the fact that it's just not simplified. Because we can actually solve it a little bit more because we can get rid of the squared. Now what you want to think about is what a squared means. It means it times's this by itself. So when I write that, I should write 4x plus 1 times 4x plus 1 minus 2. And then what we would see would happen is we'd have this double distribute go on. So I'd get 16x squared plus 4x then we can go the other way. Plus 4x plus 1 minus 2. And that whole thing should equal the 4's combined. The 1 and the negative 2 combines. So I get 16x squared plus 8x minus 1. And that would be my final answer. So when these have x's, your final answer a lot of times is just whatever you can get with this simplified mess. And that's the basic idea behind all of, like, a lot of these composition functions. It's like, plug in this, find your answer, plug in that, get your second answer. So try the problems on the worksheet today. And if you have any questions, please ask.